Okay, so are we good?
Yeah.
Okay, so what we're going to film right now is trying to understand an electron transport chain, which in the songs you're going to learn a little bit later goes like this. A-na-na-na-na-na-na-na-na. And when we learned in metabolic reactions that things get broken down in many small steps, this is what we're going to model right here. You are a membrane, okay? I am a molecule that has 2 electrons attached to me. I just got them. Am I reduced or am I oxidized? I'm reduced. I am now going to pass them to an electron acceptor in this membrane. Okay? She just got what?
Oxidized.
No, she just got reduced and I just got oxidized. She is going to pass them to the next member on the chain, and she just got reduced and she just got oxidized. Now, while she is reduced, she has superpowers, and she's like, "Ooh," because she has what? What does she have? Energy. She is going to take her superpowers, and she's going to grab a hydrogen from that side of the membrane and put it on this side of the membrane. Think. She is taking a hydrogen from this side and concentrating it on this side. You remember what I'm talking about? Okay, now she's going to pass again. She just got what? Oxidized, and she just got reduced. This is like hot potato. Okay, it starts out with the most energy here, and every time we pass it, we have a little less energy. Okay, and again, be superpower and flip a hydrogen. Yay! Okay, now the thing is, up comes another high energy set of electrons, and up comes another high energy set. Flip it over there. Now, you can only hold 2 electrons at a time, and you can't set them down. So let's keep going and let's see what happens. Good job, superpowers. You can only hold 2. Uh-oh, you can't hold 4.
Oh my
What's going on?
He just died. The body just died.
It's all documented too.
All right, now, a couple things I want to point out. Okay, good job, electrons. So let's talk about this just for a minute. We have been concentrating hydrogen ions to this side of the membrane. Do you agree with that?
Yeah.
Can we do something with that? Is that potential energy? Yes, right? Because we have just made a chemiosmotic gradient. That's a difference in what? Difference in what? pH, concentration, and charge. So now, this concentration of hydrogen ions, it's like we're trying to get into Disneyland, okay, right? So all these hydrogens are here, and we need to go through a turnstile to get into Disneyland. So they are wanting. Finally, the light is green. When they go through that turnstile, they're like, yay, and they come inside. When they go yay, and they come inside, they snap a phosphate onto ADP, making it ATP. I am coupling 2 reactions here. I am coupling an electron transport chain with the synthesis of what? ATP. Now, let's talk photosynthesis for a minute. I told you this is the highest amount of energy right here, yeah? How did these electrons jump to a higher energy level so we could even start this bad boy right here? Energy from the sun excited the electrons so they could go na so we could make some ATP, but we're not done. Okay? I need to end up, I want this chain to keep going and keep going, so I need an electron acceptor right here. Here is the electron acceptor. I am NADP, and I just became reduced NADP. Are you bringing it? Are you bringing it? I'm going to take these electrons, and I'm going to go right here to some CO2, and I'm going to give these electrons to CO2 multiple times, and what am I going to make? Glucose. Okay. All right, we're good, thank you. All right, so